Welcome to today's session, Building Your First Generative AI Application. Like I said, my name is Alex. I'll be your MC for today. Before we happen to begin, we are just going to do some housekeeping first. Everyone can discuss and ask questions in the chat. Please feel free to utilize it. However, as Dan is instructing, we may not be able to read all current questions, so just please be patient. We'll ensure we save some time towards the end of the session for any unanswered questions. Lastly, a follow-up email will be sent with today's recording, so that will be followed up. I'm going to take a moment here. I apologize for my screen to work, so just bear with me one moment, as this is not presenting. So one moment as we work through some technical difficulties, and then we'll be on our way. Apologies. Let's see if this works. Okay. Apologies for the odd display, but let's see if this works. Perfect. And we're off. So with that said, I just want to take a little bit about who we are as a company, Excel ILT, the three brands within that, and how we can service you. So as I said, Excel is the ILT, instructor-led training. It's a collection of three brands, those three brands being Accelebrate, ExitCertified, and WebAge Solutions. So the collection of these three brands really helps us allow to service the entire life cycle of employee technical training. Accelebrate, will start there, is actually known for providing customized courses for teams in advanced technology and software application training that enables business teams of all skill levels to accomplish their project end goals typically. With ExitCertified, we actually provide authorized training from leading technology vendors, and we also offer a combination of official courseware and internally developed custom materials, which helps provide clients with comprehensive education and industry-recognized certifications. With WebAge Solutions, we actually are able to create upskilling programs for entire organizations. So these unique, specialized upskilling solutions are tailored to each organization's specific needs and goals, and we can pivot throughout the training to help assess where those are going to end up. So with our three brands, like I had mentioned previously, we really provide a full suite of services and resources to help teams or organizations alike really meet the growing demand for professional development. So we're excited for all of you to join us today, regardless of which three of these entities you might have heard about this webinar from. But with that, I'm excited to introduce our instructor for today, Dr. Dan Gran. Dr. Dan Gran is a seasoned AI researcher, cybersecurity expert, and educator with a proven track record of bridging the gap between cutting-edge technology and practical applications, His career spans from early web development to government R&D, with a current research focus on the critical intersection of AI and cybersecurity. Dr. Gran is dedicated to both securing and ethically challenging the technologies that we currently rely on. He's a sought-after educator, conference speaker, and published researcher, which gives me great appreciation to introduce Dan today for our session. So I'm going to pause and share it over to you, Dan.
Hello, everyone. So a slightly different format for the webinar than usual. I am going to start with about 10-15 minutes of talking through some basics about how generative AI works at a fundamental level, and then move directly into doing some hands-on coding. Now, if you want to follow along, I have dropped the link to the Google Collab notebook in the chat. You will need two things to, let me pull up the chat here. Yes, I can see a question about sending it to the Q&A. Can you handle that, Alex?
Will do.
Here on the screen is the notebook. If you open it up in your Google account, you should be able to copy it to the drive. I will give people time to get a Google account if necessary and get this up and running. It's that tiny URL. And the second thing that you will need for this is an OpenAI API key. You can go to platform.openai.com to get an API key. Once you log in, you will go to the dashboard, the API keys. You do need to fund your account with $5. We're not going to come close to using the $5 today. And really, that's going to let you go a long ways towards actually experimenting with this technology. So I will give everyone a chance to get that OpenAI key and get it loaded. And could I just get a confirmation that my screen is showing up?
It is.
Okay. I don't have the nice outline or anything. So let's talk about generative AI and how it works. When we have text or imagery or audio or any sort of input format which is coming into an AI model, it is not going to go directly to that model. So the model is not reading ASCII. It's not reading the text directly as we would in a file. Instead, the first thing that's going to happen is that the input text is going to be tokenized. And this means to break down the text into different units and have those represented by an ID. Some very early versions of tokenization just said every word is going to have a number associated with it. And you might say the word A has the number 1, the word brown has the number 2, and so on and so forth. After that tokenization, the tokens are going to be embedded. This means that they're going to be converted into a vector or a list of numbers that represent the semantic meaning of the model, of the word, excuse me, of the token. Now, the meaning here is going to be contextual, so it's going to work with the information around it, and it's going to be complex. We'll talk about that in a little bit. After the model tokenizes the text and embeds it, it just predicts the next token. Now, there is some complexity here about how the next token is selected, but effectively what happens is the text that we have comes in, there is a probability for all the different possible output tokens, and then the model, an algorithm selects the token and continues to move forward with that selection. So you can imagine if our text was a quick brown fox jumps over the lazy dogs, and we only gave it a quick brown fox, the next token might be jumps. And then if we were going to predict the next token again, it'd be jumps over the lazy dogs. And so we could keep adding on our next token and predicting the next token. Now, once we've either reached a maximum number of tokens or a special token saying that the model is done, we end this process and we can convert the tokens back into text. It's a very similar process for imagery and audio with just different ways of doing the tokenization and embedding. So let me step through this in a little bit more detail. We're going to be working with GPT-4o Mini today, which is just a really cheap version of GPT-4o. A little bit less capable, but still very powerful. And if we were to give it the input text, every artist is a cannibal, every poet is a thief, which if you know that reference, I'd love to see it in the chat. We would first tokenize that, and that we can see here, the tokens are divided by these pipe symbols. So we have every, and then space artist, space is, space a, space can, and then ibble. So here we have the word cannibals divided up into 2 different tokens. This is because the tokenizations that we use, algorithms that we use today, work at the subword level. So they don't always use the entire word. Sometimes they use parts of it. And this means that they're robust to misspellings, to words that are really uncommon, to numbers, to code. And you really don't have to worry about, is every word that I want represented in this tokenization dictionary. So after it's split up into tokens, it's converted to the IDs. And you may notice here that every and every is repeated twice. We have every artist and every poet, but we can see that the token IDs for them are different. That's because there is an uppercase every here and a lowercase every here. So we know that this model is going to be case sensitive, which could be really useful when you're working with acronyms that may be similar to words themselves. But we can also see that we have two copies of the token is, and they have the same token ID, both of which is 382. If we move on to, from these token IDs, we can now embed them. And the embeddings are a way for us to put these tokens into a series of real numbers, a vector array of floats. And this is useful because we can do mathematics on those vectors. And these vectors will capture the meaning of the tokens. They have been learned over millions and trillions of examples, and they are unique to each token. Now, a classic example of token math is this relationship right here. We have king and queen and man and woman. Now, there's only two dimensions in this, and usually the embedding dimensions are in the hundreds or larger. And so we see king is to queen as man is to woman. Or if we were to do some math, we could say king minus man plus woman would get us to queen. This can be really useful to explore relationships with tokens, but it also allows us to see that some meaning has been embedded or put into these lists of numbers. Now, the embedded words can have more than one meaning. Bank, for instance, can be both a financial institution or the side of a river. There's a phrase that I've heard often: a baker needs dough to make bread. And when it's spoken, you could say a baker needs dough, like manipulates the flour and water to make bread, like a loaf of bread. Or it could be a baker needs money, dough, to make bread, another slang term for money, or any combination of those. So there's just alternating meanings when it's spoken. Now, usually these meanings can be inferred from the context of the word, and the embeddings that the model uses are going to capture all the meanings of the word as it is used in the training information, which these days is the entirety of the internet. So there's almost the entirety of the internet. So there's just lots of information to train on. And so they'll have definitions of words that don't even appear in the dictionary yet. An example is if a teenager came to me and was like, whoa, that skateboard is totally Sigma. I have no idea what that means. I'm still trying to figure out if that's an insult or a compliment. But these LLMs, these models already have an understanding of those words and an embedding, and they're able to interpret that. I think it's positive. And that's simply because they've seen those words used repeatedly over and over again in a lot of different contexts. Now, I want you to think about like a good memory that you've had. Usually the memories are not singular, so they're not particular moments in time, unless it's something like a loved one hitting a home run. So there is like one particular moment. It's usually like an amalgamation of many small moments. So if I think of a really good vacation I had, it's lots of different snippets of memories from that vacation, which contribute to an overall good memory. Now, embeddings are very much like memories for models. They help models understand the holistic context of these words or tokens that they're looking at, and they can help inform how the model is going to respond to those tokens in the future. But there's also an element of forgetfulness. The models can't repeat everything they've seen before because they have to compress the information down into these smaller representations. And there's just too much information that they've been trained on for them to reproduce everything faithfully. And this is where we have hallucinations come in. Even though the model has a good understanding of a lot of things, it can't just reproduce things verbatim. It's approximating things. Now, a very interesting thing here is that the embeddings in the model are very similar to the way that our brain activates, and it's shown through fMRI patterns. And this is a good indication that both our brain and the large language models are learning some underlying foundation of reality and language rather than just the models are just learning something, but it's not tied to anything. They do seem to be learning similar things to what our brain is learning, which is a good indication that these systems are working well. After this, there's the prediction of the next token. This is a complex step. This is where all the mathematics of the model come in and some algorithms. But honestly, this part we can think of with much more abstraction. Think of it as just adding the next token again and again and again. So here we have the input, it's a beautiful day, don't let it get, and then we have some options of what token could come next. And depending on our algorithm, which selects the token and controls kind of the creativeness or randomness of the output, we could see any of these different tokens come out of it. Also, if you know the context for the quote, I would love to see someone throw it in the chat. So here it would go, it's a beautiful day, don't let it get, you, to, and so on and so forth. Now, once we have this, the text can go back to the user, and we have effectively that full cycle of tokenizing text, embedding it, predicting it, eventually stopping, and then going back to the user. Now, this isn't how LLMs are deployed. We don't just throw them out there as these simple systems. In reality, there's a larger architecture surrounding them. We have a user who will work with, sometimes there's a cache in front of it. There's a lot of enhancements that go on. This is where things like tool use, retrieval, augmented generation fit in. Definitely guardrails to make sure that there's appropriate safety, both on the input and the output of the model. Then the model itself is used, and really this generation step is the only one that we talked about earlier. And then there's just simply lots of other options and lots of other connections as the outputs of the model get routed to the user or to some action for them to take. So holistically, LLMs are not deployed as individual little models that people interact with. They are big systems to work with. Now, today we are going to build a couple things. We're not going to build a user. That will be us. We are going to build a little bit of enhancement around an LLM. We're going to work with the OpenAI model gateway, the API, and then we are going to add a structured output to our model and pass it back to the user. So in particular, we are going to build an email sorting application. Now, here is the two URLs which are relevant. I will copy them into the chat. And when you open up the email sorter notebook, you should see something like this. You might have to, there might be a button here that says copy to drive, where you need to go in and take this notebook and copy it into your Google Drive so that you can modify it to suit your wishes. The link will continue to work throughout the entirety of the webinar. And as I put the code in it, then eventually you can copy a finalized version, which has all the functionality in it. Now, a couple of things that we'll need to do in order to use this notebook. We're going to work with this data set that I created. It is LLM generated because I couldn't find a good real world version out there. And it is simply let me see if I can open this with Google Sheets. It is a comma separated document that has emails in it. So that each of them have a subject and a message. This is similar to the .email format, but I did strip out things like the date, the from, and so on. Now, we're not going to connect to an actual Gmail or an inbox at this point in time, simply because those API connections can take quite a bit of time to set up. And instead, we're going to focus on the LLM component, and we're going to say that the LLM is getting the emails in this format, and we can figure out the tooling to make those connections at a later date. So once you have a copy of this notebook and you've downloaded the emails.csv dataset, you'll want to go to this Files tab on the left, and you can click Upload and upload the dataset right there. So you should be able to see the emails.csv dataset in your files. By the way, if you encounter any issues during this, please drop them in the chat. I might not be able to address them, but I will try to. The second thing you'll need to do is to set the OpenAI API key. You can get that from this page. It's under the dashboard API keys. As I mentioned before, you may need to seed the account with $5, and that will go quite a long ways. If you create a new secret key, you give it a name, it will need some permissions, and then you can create it. And I already have a key created. Now, once you have that, you'll go over to the Secrets tab here and create a secret right here, add a new one, name it OpenAI API key, all uppercase, paste the value into the value here, and make sure that you have notebook access enabled. So once you have that, you will be able to get that OpenAI key, API key from the notebook without sharing it with anyone else, which is the reason why we're using that secret there. Okay. So going into the notebook itself, the first thing that we're going to do is connect to the OpenAI API. Now, Collab itself does include LangChain, which is the library that we'll be using today. LangChain is a way of building systems around LLMs that are much more complicated, including techniques such as retrieval augmented generation, or RAG, and agents. They do include LangChain, but they don't include the LangChain OpenAI library. So we'll begin by installing that. That is just a pip install with Q for quiet and the LangChain OpenAI library. Now that once we have the libraries installed, we're going to set the OpenAI API key environment variable. There's probably an easier way to do this, but all this does is copy the OpenAI API key from the secret into the environment variable. And I'll run that. There's nothing to put in there. So the next step for us is to actually try connecting to the OpenAI API. And we will do that through this class, Chat OpenAI. Now, a lot of the APIs these days don't just give you text completion. You're actually going to work through a chat interface. Now, that doesn't mean that the model is only useful for chat bots or chat completion. It just means that behind the scenes, you can treat the model as a chat bot, even as it's doing non-chatbot work for you. So let's go ahead and instantiate our chat OpenAI instance. I will call it LLM. And if you notice, I have some nice Gemini predictions going on right now, but these aren't always correct as LangChain changes rather rapidly. So I'm going to instantiate chat OpenAI, and I'm going to do it with the model GPT-4o Mini. And as I mentioned, this is a smaller version of GPT-4o, much cheaper to run. Today's lab should take, or today's demo should take a couple cents to run, and US cents. And it is, if we were to transition to 4o Mini, it'd be a little bit more, but not significantly. In terms of development, always take advantage of scaling laws. So start with the small models and test with that, and only move up once you have a compelling reason to improve the performance of the model, or if you're going to move into deployment and you just want the highest accuracy possible. So we have the model here, and this is all automatically going to pass the OpenAI API key in from that environment variable. So that's all I need to do. And I can test that by running this notebook, running the cell. I'm going to do that by hitting Control Enter. So if you see the cell running like that, I've hit Control Enter. Now we can talk to the LLM directly by using the invoke method. And this is essentially all that we need to do. We can just pass in a string, and this will go directly to the OpenAI API. It will respond and give us an output. Now, the output is rather complicated. It is this class AI message, and that reflects the fact that it is a chat OpenAI. But the part that we care about for today is the content. So it would be AI message.content, and it responds with, hello, how can I assist you today? So we've made this connection. We also can view some metadata about this. So for instance, we see HiGPT has 11 input tokens, 9 output tokens for a total of 20. Probably this is including some extra information besides just HiGPT, so that's why it's at 11. We can see the model name and see that this version was updated on July 18th. And I think that's most of the useful output in that right now. So we have it working. We've been able to connect to the OpenAI API. Let's go ahead and load in our emails. Now I have stored these in a pandas data frame. So we can use the pandas.readCSV method to load in the emails. And I will just use head to make sure that we can see some of the emails in this data frame. So it does have this unnamed column. I saved it with an index column. I probably should have dropped that. And then it has each of those emails in it. Now, these are strings. We can see that they have some new line characters at the start. But let's take a look at what just one of these emails looks like. So I'm going to print the 4th email here. And I can do that using pandas lock attribute function, whatever it is there. And this lock says I want the 4th email 4, so that's actually the 5th row here. And then I want the column email. It's kind of like indexing in Excel. And we can see here is the message. All of the emails are to Iva, and this is a message asking about a weekend picnic. And from her friend Harper. So let's see if we can sort this email. To do that, we are going to create a prompt, which we'll send to the LLM. And we're just going to make it the easiest possible prompt. We're going to say llm.invoke. Remember, that's the method we used up above to test it and to call hi GPT up here. And with the llm.invoke, I'm going to use Python's f string, and I'm going to use 3 strings here, or 3 double quotes, and that will let me create a multi-line string. So all of this in here is a part of the string. Now, once I have it in here, I'm going to ask the LLM to sort the email for us. I'm going to say, please sort this email. And I am going to give it one of the emails. Let's give it this 4th one up here. So I'm going to copy that, put it in here, and this line right here will interpolate our email into the prompt. So the model is going to get, please sort this email, and then the content of the email. And you know what? I'm going to go with .content here so that we can see it a little easier. This will get the actual content of the response. And then the other thing I'm going to do is I'm going to, you know what? Let's get response as a variable, and then we will print the response so that it prints the response itself with those new lines. So right here, we see that we've done this invoke, and it's not really doing anything. We've asked it to sort the email, we've given it the email, and it's kind of just responded with the email itself. Let's try a different prompt. I'm going to ask, is this email personal, work, shopping, or maybe account info? And now we have it. It is responding. It's saying this email is personal. It's discussing plans for a picnic, and it's addressed to a friend, and it's not related to those other ones. So we do have the model responding with a category. Now, right here, we've put in personal, work, shopping, or account info. So we've kind of manually set those categories. Now, you could probably imagine that if we change this to another email, let's say 10, this email is related to shopping. Now it says related to shopping instead of this email is personal. So working with this output isn't really ideal. What we might want to do is clean that up so it's easier to use. So I'm just going to copy this entire cell here and paste it into our new one. So that we have this old version working, and now we can work with the new one. And I'm going to give an instruction to the LLM to only respond with the category. Now, when I do this, we should expect that it's going to just give the category in response. Because this is an LLM, there may be times where it doesn't work out exactly right. But the majority of the times, if I look through here on different emails, it's going to come up with the category that I wanted. Now, this is useful. I think we can work with a single word output like this, and we could easily iterate over all of the emails and assign them to categories. But let's say that we want to expand this structure system into kind of a smart email system where not only are we putting the email in a folder, but we're going to give it a priority. We're going to create a list of tags for it, and we're going to extract the names of the people in the email. and maybe some of the entities like the person where you're place where you're shopping, so that you have this much more complex email system that's doing things for you. So to do that, we're going to use structured output. And this is a way of allowing the model to respond with the exact sort of output that you want. And in this case, it will be a Python class. So if you haven't worked with Pydantic before, this is a way of specifying classes. And I'm going to create a class called email sorting. Let's call it email, maybe metadata there. And we are going to subclass that from base model. Base model is what says to Pydantic, this is a class that I want you to care about. And we're going to create 4 fields here. We're going to create a folder field. This will be a string. That's what this structure means. And then we can give a description of this folder right here. And I'm just going to say folder to sort email into. For the next, oh, look, we already have a nicely generated response here. I'm going to type it out just so that, just because I want to make some tweaks. I'm going to create a priority field. This will be an integer instead of a string. And I'm going to give it the description of priority of the email. And then I'm going to say, 1 is low, 5 is high, just to make sure that what we and the model think is low and high are the same things. Now I'm going to add in tags. This will be a list of strings, and we will do that same sort of description. And I'm going to say tags for the email to allow easier filtering and sorting. Give it a little bit more info there. And the last one I'm going to add is the names. And this will again be a list of strings. And I'm going to say this is, let's go with proper nouns. So this would be like not just man, but Steve, and not just store, but Walmart. So like proper name. And so from here, we're hoping that the model will extract a folder, a priority for the email, give it some tags and some names. And to do this, I am going to call our LLM dot with structured output, and I'm going to give it the email metadata class. That's all that I need to do in order for the model to respond with the email metadata class. So now I can use the same prompt that I was using before. And in this case, I'm going to change it slightly. I'm going to say, sort this email. Available folders are personal, work, shopping, and account info. And then let's run this. Oh, so we have a content here, and it says attribute email metadata object has no attribute content, so I need to remove that. And in response from the LLM, we have an email metadata object. So this is email 5. Let's take a look at that email real quick. And we can see that the subject is meeting rescheduled, so tags are meeting rescheduled, scheduled, letting know our meeting has been rescheduled. Please let me know if this time doesn't work for you. This could be personal, it could be work, but given the voice, work's a good guess. 3 is a decent priority, kind of in the middle. and we have it extracting the name Iva and David. Iva and David are the proper nouns in this message. So it looks like it's working pretty well for us. Now, let's say that while this is working, it's a little bit of an annoyance to work with it. And let's say that we want to make sure that we have a prompt that is separate from the way that we call the LLM. So right now we have LLM with structured input, output, invoke, and then we give it all of our prompt, and we put in our email. And really, it would be great if we could just invoke it with only the email and all of this was hidden. So let's create something called a prompt template. And we'll move down here to step 4. And we've already imported this chat prompt template. So I'm going to create a variable prompt template and instantiate chat prompt template. And there's a from messages static method here. And this from messages static method is expecting a list of tuples. And for these tuples, it will start with a user or like a role, and then it will have a message. So the roles that we're going to work with are system, human, and then the other one is assistant. So the assistant would be the model's response. You can kind of put words in the mouth of the models, which can be useful over time. But what we are going to do for this prompt is we are going to say, you are an email sorting AI agent. Available folders are, and I'm going to put in a just a standard Python replacement here. But notice that this isn't an F string, so this isn't going to try to look for a folder variable. Instead, that's part of the template. And then for the human part, I'm going to say sort this email. And I'm going to add some new lines and then actually give an email. Oh, and autocomplete went crazy. So in the system, we're giving some system level instructions. This is going to be useful to help kind of prioritize some information to the model. And here we're saying, this is what you're doing. Your job is to sort emails. And these are the folders that you can sort into. And then the human is asking for this email to be sorted. Now, if we use this prompt template, we can use it like this. Prompt template.invoke. And we will pass it a dictionary of folders, or sorry, a dictionary with the key folders. Let's put this on new lines to make it easier to read. And here we can put in the personal, work, shopping, or account info. And we'll also put in an email, and in this case, it is the emails.lock5 email. Now we are going to get an error because the prompt template does expect strings, so I will convert this list to a string. And I also put in folders here and folder up there. So let's rename that into folders. So now we have a output. This one's a little bit complicated, but we can see it has chat prompt value, and then it has a attribute of messages. There is a system message with the content, you are a sorting AI agent. Available folders are that. Yes, it should be personal. Thank you, Daryl. And then it has a human message that has the email in it. So this is now the prompt, and we can invoke the the prompt to get that messages, which we can pass to the LLM. Now, because I don't want to keep typing that, let's put folders into a constant. Now, this here is a very rudimentary example of retrieval augmented generation. RAG, as it's commonly known, uses some form of going out and getting content to help tailor the outputs of an LLM so that they're less likely to hallucinate. Often this is going out to a search engine, finding content which is relevant to the user's request, and then inserting that into the query so that the model can respond based on that. And instead here, we are using a constant to provide a context to the model of the available folders. If we wanted to, we could, instead of making this available as just a list, we could go out and get the folder options from an API to figure out which folders were available in the user's account. Perhaps we could even ask the human which different folders they wanted to sort into, and so on and so forth. But this is a very simplistic example, and I'll run this again just to make sure it continues to work. So now that we have this, let's use the LLM with the prompt template. So just like we've done before, we'll do LLM dot, and let's make sure that we have that with structured output, email metadata, because that's the class we want. We're going to invoke the prompt template, and we are going to give it the folders and the emails, just like up here. And here we're getting work priority 4. Oh, it's gone up a little bit. Remember, these do have inherent variability in them, so sometimes there's going to be some variation between the exact responses that we're getting, which explains why we had, I think, a 3 up here for the priority and a 4 down here. And we're getting there. This is working better, but the structure this is a lot. We could wrap it in a function and just pass in the email content. But there's something called the LangChain expression language, which allows us to make this simpler. So we're going to use LCell, as it's called, and we're going to use that and something called a partial template to simplify this. So I'm just going to start with creating a variable for our structured LLM. And this is just, we're going to give it that structured output. So it has the email metadata and it's just structured LLM. The second thing I'm going to do is I'm going to create a partial template. And this will allow me to take the prompt template. I'm going to call the partial method, and I'm going to pass in the folders. So now whenever I call partial template, I don't need to pass in the folders because the folders will already be provided to the template. I only need to pass in the email. And then I'm going to create an email sorter, and this is where the LangChain expression language comes in. I'm going to say first invoke the partial template, and then I'm going to use the pipe operator to tell it what to do next. And with that partial template, I want you to invoke the LLM. Now, this is one of the simplest examples of LCell, and it gets much more complicated, but it's a way of chaining, hence the name LangChain, chaining together different LLM operations and the tooling which can go around them. So this is an absolute simplistic one, but now that we have email sorter, we can just say email sorter.invoke. I'll use the autocomplete, this 5th email. And when we run it again, we get the same output, a much shorter way of calling it and much easier to use. So now that we have it working here, let's run it over all of the emails. And I'm going to try to import something here. Don't know that this is included. It is included. This will give us a progress bar. So I'm going to go ahead and store the information about the emails back into the emails. So I will add a column for the folder. I'll add a column for the priority. I'll add another one for the tags, and I'll add another one for the names, all the components here. Now, instead of saving these values back into the pandas data frame, we could easily read in an email, use these to update the email, and even call maybe an API to update that folder. And now I'm going to iterate over my rows in the pandas data frame, trying not to just autocomplete everything here. And we'll call the email sorter, and we will use invoke row email. So this is going to give us the email for this row, and it's going to store our email metadata in the result. Now, this is a little bit of a complicated syntax, but effectively I'm going to save the result.folder into the pandas data frame. You don't do it right back to the row because that doesn't persist past the iteration here. So you save it right back to the data frame using that location command, which is kind of the indexing. So we're going to save the folder, the priority. We're going to join the results into a comma separated values, and the same for the names, although there is a space there. And in order to test this, I'm just going to say if I is greater than 5, break. So this should only run for the first 5 emails. And here we can see we have the emails, we have a folder for each of them, none for the latter ones, priority, tags, names. And with this, I can remove the if and let it run wild. There are, I think, 115 some emails in this. The LLMs are slower than APIs in general. There's a lot going on in the back end. They are working with GPUs and lots of transactions, so it can take some time. And another option is to batch your transactions, so it goes a lot faster if you just sent them all at once. I am sort of asking for one, updating it, then asking for another. It's not the most efficient way to do it. But then at the end of the day, this will go through and we should be able to see all of the folders, priorities, tags, and names. And one last thing I'll do is go over to my usage here, which isn't always that high. But over the course of today, which included a lot of testing for this as well, you can see that I've only used 4 cents, which is a reasonable amount of money for working with all of our emails. Now, where would you go from here? There's a couple places. First, you could take some training from us. We're constantly working to improve it. We have some greatly updated and improved courses coming out soon. And we specifically will train around LangChain, OpenAI, or whatever model you want. You can learn more about LangChain from their website, which I don't know why there's a redirect notice. Here is an introduction to LangChain, the documentation. The other things you might want to learn about is LangSmith, which is a logging framework for LangChain, and LangGraph to add in agents. The agent would allow you to interact with different APIs and use tools almost like it's a robot just doing things for you. Now, Here we can see we have our output. It did take some time. It wasn't efficient. And I promise that building this example was not an excuse to sort my wife's email inbox with the current like 10,000 unsorted emails in it. So this is our example. This is the first Gen AI application. It's not a chat bot. You could integrate it into your email system now, and I will open up for any questions. Sorry, I know it went a bit long there. Feel free to drop them in the chat, or I don't know if you can unmute.
You should be able to
Okay.
put them in the chat, not unmute.
While we wait for some of those questions, did you have like some closing slides at all?
I did, yeah. If you wouldn't mind, I'm going to grab the share. And I just wanted to really quickly touch upon some important information for everyone that's joined us today in regards to some of the things that we are promoting here. In lieu of this course, or as a follow-on, excuse me, to this session, we have a course, Comprehensive Generative AI for Developers Training. And I'm actually going to throw something in the chat here, a few links for everyone to see, which will be included in our follow-up emails to everyone here. And the links that have been put in the chat will be included in that follow-up email. So what you can see here is I've shared the WebAge Solutions link to this follow-on course, as well as the ExitCertified course. Now, with the ExitCertified course, you can receive a 60% discount if you use promo code SAVE60, that's 60 at checkout. The WebAge discount is automatically applied. I just wanted to make that distinction. And then lastly, I do want to note that we are offering some discounts in addition to that follow-on course. We are offering 20% off on our Flex accounts, which locks in savings for your annual training plans for an entire 12 months. In addition to that, as a thank you for you all joining this session today, we are using a promo code TRAIN25, which will offer 25% off a variety of courses, including self-paced, public, private, team training. And the only thing is that training is booked and completed by December 31st, 2024. So I've included a contact us link there too, if you're interested in any group training or future training with us. So I just want to say thank you all for joining, and I'll pause and see if there's any other questions that come through.
Not seeing any. I think we're good to close
Perfect.
it out. Thank you everyone for coming.
Thanks, everyone. Have a good day.